11.1 Circumference and arc length. How can you find the length of a circular arc? How can you measure angles in radians? Let's take a look at how we measure the length of an entire circle. We have two formulas, c equals pi d or c equals to 2 pi r. In this case, since I saw that the radius was 4, I put it into this formula and my answer is 8 pi. Now remember, pi is about 3.14, so 8 times 3 is about 24. So this answer makes sense once I put it in the calculator. Now this one isn't the entire circle, but only 1/4 of the circle. So I'm only take 1/4 of this answer, and I'm going to get 6.3. The next one, and again, this is part of the whole circle, so I see I'm taking 1/3, and then I use the pi d formula. I can see right here that my radius is 5, and so I'm going to use the pi d and make the d 10. And this answer is about 10.5. I want 5/8 this time, 5/8 of pi d. Again, the radius is 3, so I know that the diameter is 6, and I get about this answer. So what I've been using is the circumference formula, c equal to pi d or c equals to 2 pi r. All right, let's go ahead and do a problem. I want to find the circumference of a circle with radius 9 centimeters. So I write out the formula, c equals pi d, and then I write pi, and I know my diameter is 18. Now that's going to be in centimeters. We like to put the 18 in front, so 18 pi centimeters would be the exact answer. If they ask you to round, then you're going to put that inside using the calculator, and that'll be about 56.5 if you round to the nearest tenths centimeters. And that's again about 3 times 18. Now what if I have the circumference? So in this formula, c equal to 2 pi r, and I have my circumference is 26, and I'm looking for my radius. So I'm going to divide both sides by 2 pi, and when I go ahead and reduce, my radius will be 13 over pi, and that'll be in meters. Now if you want to round that and put it in the calculator, the answer is about 4.1 meters. And again, that's about what you get when you take 13 and divide it by 3. That would be a good estimation to use. Okay, your turn. And here are the answers. Let's go talk about finding the length of part of a circle, which we call an arc length. So what we're going to do is we're going to take the fractional part, so whatever part of the circle we want, a half or a third, and then we're going to times it by the circumference. And the circumference could be in the 2 pi r form, or it can be in the pi d form. Let's go ahead and take a look at this problem where I've written out the formula in all the cases. I'm looking for the length, so I'm going to put the measure here, and my measure is going to be 60, which amounts to 1/6, and then I'm going to multiply it by the circumference, and since the radius is 8, I'm going to write pi times 16. Now if I want an exact answer, I can do some reducing, and the exact answer would be 8 pi thirds, and the answer would be in centimeters. If I put it in my calculator, I'm going to get about 8.4 centimeters. In this particular problem, my length is known. I have this length, and it's 4.19. I do have the degree, so that's 40, and that amounts to 1/9 times c. Now I'm being asked for the circumference, so I'm going to solve for c, multiplying both sides by 9, and I'll get about 37.71, and I label it in inches. Last one, I know the length, 15.28. I don't know the measure. I'll put m here, divided by 360 times, and then my circumference is going to be 2 pi, and then my radius is 15.28. Now what I'm going to do is I'm going to isolate m, and to isolate m, I'm going to multiply by the reciprocal. So I'll have 15.28. I'll be multiplying by 360, and then dividing by 2 pi 15.28, and I do think I have an incorrect length here. This this 15.28 should have been 44. So this should have been a 44. I had that incorrectly. And then everything else should be okay. So this was 44. And when I put that in the calculator, I'm going to get about 165, and this is in degrees because I'm looking for the central angle. And that does look like a big angle here. It looks like almost a semicircle, but not quite. Your turn. And here are the answers. Here's our next problem with an apply problem. We want to find to the nearest foot how far the tire travels in 15 revolutions. Well, one revolution is a circumference, and we do need to know what the diameter is. So I add all of these lengths, but since the question is being asked to find it in feet, I'm going to have to convert this into feet by dividing it by 12. So that's what the diameter is in feet. So now I can go ahead and find 15 revolutions, which means I am going to take 15 and times it by the circumference, which is pi d. And remember that my d is 26 over 12. So I'm just going to go ahead and put all that in the calculator, and that'll round to 102 feet. So that's how far the tire will travel in 15 revolutions. All right, let's take a look at a track problem. We want to find the distance around the track, and it looks like that there's a semicircle here, and then we have another semicircle right here. Okay, so what we're going to do is we're going to do half a circumference for this red arc, and that'll be 1/2, and then this is going to be 2 pi, and our radius is 36.8. Now this straight strip right here, there's two of them, so I'm just going to take 2 times 84.39, and then I want to take 1/2 of this blue circumference, which is going to be 2 pi, and my radius here is 44.02. So there's some reducing I can do, and then I can go ahead and put it in my calculator, and I will get about 422.7, and this is in meters for the distance around the track. All right, your turn. And here's the answer. Now let's talk about how we measure angles in another way. We measure it in terms of radians. Okay, so let's take a look at this smaller circle. It has a radius of 1. And if I take this radius of 1 and make this arc the same length, so this length of 1 and this length of 1, we say that this angle is intercepting a radius of 1, and we call this angle 1 radian. So it's different from calling it degrees. Let's take a look at the big circle. The big circle has a bigger radius, and if I were to put the radius right here, and it has the same length as this length right here. So this arc that this angle intercepts, that's inside this angle, is 1 radian. So this angle is described as 1 radian. So again, the thought behind this is that the angle can be thought of as the length of the arc associated with that angle in terms of radians. Now what's interesting is going all the way around is 360 degrees for us. Well, going all the way around in terms of radians is 2 pi r. So it's 2 pi radians. If it happens that the radius is 1, it'll be 2 pi. That's how many radians there are in every circle, not just a radius of 1, but in all circles. It's 2 pi of these radii. So we say 360 degrees, and we say 2 pi, measure the entire circle. And that is a measurement. We don't call it degree measure, we call it radian measure. There is no symbol for radian. We don't have a little circle or anything like that. All right, let's take a look at converting between degrees and radians. It's really a scale factor. Okay, so pi radians is 180 degrees. That's because 2 pi, the entire circle, is the same 360. So if you reduce by 2, we use this as our conversion factor. Let's go ahead and do this problem. We want to convert 45 degrees to radians. Okay, so one way to look at it is this proportion that I have said. So we're going to write pi over 180 degrees is equal to radians over degrees. So it's a proportion, something that we have been doing a lot with. And we want to convert to radians. So we know our degrees is 45 degrees. So we have pi over 180 is equal to, we're going to call it x for radians, and then that's going to be 45 degrees. I'm going to solve for x, and that means I'm going to cross multiply 45 pi all over 180, and I can reduce, this is going to be 1, and then 45 goes into here 8 times. So this is no, it's not 8 times, it is 4 times. 4 times. So this answer is going to be pi fourths. So we say that this angle of 45 degrees is also pi fourths. Okay, another way you can look at this problem is you can look at it this way. We know half a circle is going to be pi radians because all the way around is 2 pi. A fourth of the way will be pi halves. That will be a fourth of the way. So here would be pi fourths. And half of that would be pi fourths. So pi fourths is an eighth of the way around. An eighth of the way around the whole circle. Okay, let's take a look at this problem. We want to convert 3 pi halves radians to degrees. We know 360 degrees is the same as 2 pi radians. So we're going to write pi over 180 is equal to radians over degrees. In this case, we know the radians, so we know this number, 3 pi over 2. And we're going to call this one, we'll call it y, the number of degrees. We're going to cross multiply, we're going to solve for y, so that means cross multiply, which means we're going to get y equals 3 pi halves times 180, so you're multiplying these two numbers right here, and then you're dividing by pi. Now what's nice is there's a pi in the numerator and a pi in the denominator that we can reduce, and therefore y is equal to 3 halves of 180, and we can do a little bit more reducing, and the answer is 270 degrees. Okay, that's one way to look at it. Another way to look at it is that we know pi halves is the same thing as 90 degrees. Remember we talked about a fourth of the circle. A fourth of the circle is 90 degrees. Well, if pi halves is 90 degrees, another pi halves is 90 degrees, and another pi halves is 90 degrees, then 3 pi halves will be equal to 270 degrees. So that's another way you can work the problem. All right, your turn. And here are the answers.